So I would like to welcome you all to the second seminar of GLODEM's AI and CSS seminar series of Spring 2021. We are extremely happy to be hosting a really interesting talk today by Dr. Elif Sürer from Middle East Technical University. Before I give the floor to her, I'd like to introduce her briefly. Dr. Sürer received her PhD in bioengineering in 2011 from the University of Bologna. She received her master's and bachelor's degrees in computer engineering from Boğaziçi University in 2007 and 2005. From 2013 to 2015, she worked as a postdoctoral researcher at the University of Milan in the EU project Rewire, where she developed video games for the rehabilitation, I cannot pronounce this word, of stroke and neglect patients. She joined Middle East Technical University's Graduate School of Informatics, Modeling and Simulation Department in 2015 and is currently working as an assistant professor at the Middle East Technical University's Graduate School of Informatics Multimedia Informatics program. She is a mentor at Metro Design Factory and Bank, Art Innovation Prex. She collaborates as a researcher in several interdisciplinary national and EU-funded projects. Her research interests are serious games, virtual / mixed reality, and reinforcement learning, which also I think summarizes the topic for today's seminar. So without further ado, I'm giving the floor to Dr. Sürer. Thank you all very much.
Thank you very much, Merih Hocam, for this very nice introduction. I will start immediately. First of all, let me share my screen. I think we should be all set. Today, I will actually introduce lots of different topics. So my purpose will not be to give very much detailed technical information, but to give some glimpse of what we do in terms of the game research. So here is a huge outline. First of all, I will start with some terminology, because I do notice that some of the terminology that we are using are actually misused, especially in Turkey. Then I will give just a brief history of virtual reality and mixed reality, and what are the current constraints, but what are the opportunities that we do have thanks to those technologies. And I will talk about some of our recent work from the collaborators. And then I will switch to the reinforcement learning section, where we will be seeing some examples from game testing by using agents and some of the enhancements that we had done to the available algorithms, and a new, let's say, relational environment, a framework that I will introduce at the latest. So first of all, we are using all this virtual reality, augmented reality, and mixed reality in generally interchangeably, but the thing is that they are at the different ends of the reality continuum. So that's why I will briefly introduce them. I mean, as the name itself suggests, the virtual reality is the broadest concept of all, and we are talking about completely virtual environments. We don't have any access to the physical environment at all. But when we are talking about augmented reality, mainly we are talking about like a layer, a static layer on top of the physical reality. So you can think of like the filters that we are using, or some of the instruction-based software that we are dealing with. There we do definitely see the physical world itself, but just some layers of information, virtual components, so that we are trying to understand the main idea about it. And it is mainly used in automation. However, a way more recent concept when you think about it, when we're talking about the mixed reality, we are actually interacting with the reality itself, like with the physical objects and so on, but via holograms. So let's say that I do see the reality completely, and I do have a virtual bullet, And that bullet just makes an impact on the real wall itself. So that what we do is that we use all the 3D physical information, but meld it thanks to the 3D hologram that we do have in our hands. And we do it by using for now with the Microsoft HoloLens mainly. There are other recent headsets as well. And now it is also possible to have like collaborative work where two people can form that holograms at the same time. So as I mean, the thing that I would like to mention here is that mixed reality is way more interactive and it is on 3D, while the augmented reality is mainly more like a static layer on top of the physical reality. And these concepts are misused a lot as well, especially simulation and serious games. So I will briefly introduce those as well. I mean, we are all familiar with the video games. So the main purpose is entertainment. They are the computer controlled software. They do have different components and so on. And these are some of the posters from my students' work. And then we do have, sorry about that, this concept called serious games. I mean, mainly it is actually a wrong adjective. The serious adjective comes from the fact that in general, the institutes are the serious institutes like the education, defense, or the industry that demands those games. But it doesn't mean that those games are not going to be entertaining. Actually, they should be entertaining, but they do have other purposes. This can be like rehabilitation, education, and so on. Recently, instead of serious games, we have started to use the transformational games, which I do think it's a way more explanatory thing, because at the end, we would like to transform people in the sense that we want them to exercise more, we want them to quit smoking, we want them to change something. That's why transformational games is way more explanatory. And the first time that I, let's say, delved into this world was when I was at University of Milan and with Rewire project. There, what we were doing was we were dealing to create a home-based rehabilitation system for stroke and neglect patients. Neglect is in general like the side effect of the stroke. Let's say that you do have stroke on your right side. Even though you don't have any problems with your eyes, you don't perceive the objects on your left. That's why what we did was by using this Novint Falcon, actually on the right side that you can see, actually it's a game controller. And previously there were like some gun heads there and it was a multi-purpose game player. But then they had changed that heading where you do see the handle of the person. What we did was we programmed this haptic device so that, let's say, after a while, if the patient doesn't see the objects on the game, we do guide them to the left side. And then, or whenever we do guide them, let's say that they need to pick an apple from the screen, they do feel the weight of that apple. And they need to do not only cognitive exercises, but also they need to use the motor skills so that they need to overcome and put it in a basket. And we had seen that this was a very good rehabilitation program for neglect patients. And we had several different games for that. And the nice thing was that it was possible to map different exercises. Let's say that the medical doctors were saying that you need to sit to stand, or you need to do like pick up items, or you need to do some multitask gathering. It was easy to map all those tasks to different games so that there was the variety and it was easy to create a rehabilitation program for like a month. And then also, whenever we are talking about a home-based rehabilitation system, I mean, we are responsible from the health of the person. And we are talking about like elderly who are like 65 plus years old. And they need to be playing those games alone at home without any guidance. So whenever they are doing something wrong, we need to warn them in advance. That's why both for the neglect exercises, but also for the posture exercises, we had used lots of color-coded feedback so that we were saying that, okay, you are doing this exercise wrong and you are about to fall. So we were just quitting the system and so on. So it was a gradual warning system. And then we continue with the serious games whenever, after I arrived to Metu as well. I not only worked on the rehabilitation part, but mainly on the training, and also we are going to see that on the cultural heritage domain. So why are the serious games such, let's say, feasible for training or education and so on? So the thing is that it is very easy to map the game structure that we are using to the exam and the education system that we do have. So you can think like the students as players, assignments as goals, the challenges or the final exam as the boss monster and so on. So it's easy to map all those tasks in a game as in an education system. That's why it is preferred that much. But I do notice that in general, people do use the simulation instead of serious games, but they are completely different things. Simulations are actually like the results of what if scenarios. So if I do ask you what's going to be the, how is the weather going to be in Ankara tomorrow? And if you give me a result as like 12 degrees and so on, that's also a simulation. It doesn't even need to be visual. It doesn't need to be interactive at all. So it's a completely different way of modeling things and answering questions. But in the games, the player is the main entity, and we are the main purpose is to interact, give feedback, and so on. So they are completely different tasks, actually. So, I mean, whenever we are talking about this extended reality, the umbrella term for VR, mixed reality, augmented reality, and so on, we do think that they are like, oh, new technologies and so on, but actually it's not. I mean, they have their like first prototypes even on the 1960s, as you may see here. But of course, thanks to the advancements in technology, it was possible to implement and use them right now. And so in 1962, there was the Centroma. So it was basically like a theater, the immersive environment where you can like watch films and so on. But to me, this was the main, the most impressive thing. In 1965, even Sutherland says that in the future, the bullets will be like real bullets, the handcuffs will be like real handcuffs, and the rooms will be like a different way of seeing things. And after seeing this quotation and after seeing the HoloLens's first demonstration video, it was like, I mean, there are 40 years at least between those realities, but think about the wisdom projected to the future. And then in 1968, the first head-mounted display was developed. And as you may see, they were like the first attempt. And then NASA had the first virtual environment display systems on 1986. And then on 1992, there was the cave. The name itself is from the Plato's cave allegory. And so you do have all these high resolution, multi-user, room-sized places where you do project the visuals to the walls and you do interact with it. Caves are still used a lot, but of course, with the, let's say, the mobility of the headsets and so on, we are on a way more different position right now. So, I mean, first of all, I will start pessimistic. Okay, so let's talk about all the constraints of the virtual reality systems. I mean, the first thing is this actually. I mean, we do think that, okay, I do have this headset, I'm going to immerse the different environment, I'm very flexible, I'm very free and so on. It's not like that actually. So we are still very much dependent on the physical technology around us. We still do have some constraints. So the technology is not quite there yet. I mean, we still do have this famous motion sickness. It is still not that much immersive. I mean, after 15 minutes, most of the people do get sick or tired and so on. So we need to work on that. And there is a lot to do on the technical side of that. And also, VR equipment is quite expensive. The development to the VR environments is very difficult. I mean, we are just now exploring. We are trying to understand what's going to be the best UX to use in VR environments, what's going to be the best way to interact with the environments and so on. So there are lots of recent studies, but we are not there yet. And also, it is not fully immersive yet. And also people do have lots of huge expectations. And these are, let's say, the recent constraints that we do have. So it's not like a bed of roses right now. And the same is true for the mixed reality headset as well. I don't know if you have ever tried the HoloLens, for example. I mean, it's like a computer by itself, and you're putting it on your head. It's quite heavy. It's quite complex, and also, at least for HoloLens 1, the viewpoint is quite limited, so that you do quite interact in a very narrow environment, to be honest. And also, for both VR and mixed reality, I mean, if you are not doing something collaborative and so on, the main problem becomes that, let's say during the training or education, the person who has the headset experiences everything by herself, and then the rest is just like watching, so that it becomes like an idle way of doing education, and it's quite isolating because of that. But of course, there are lots of opportunities. I mean, I have been working like for 4 years with VR, and I can see that it's going to be huge. So, I mean, in terms of like safety, money, and can be used remotely, I'm going to show you some examples that. So there are some training materials where, let's say, the firefighters are doing, for example, and they are really burning stuff. And in order to learn that, in order to understand how you are going to interact in case of such an emergency, you cannot open a fire each time, right? So that in terms of like safety and repeatability and the money constraints, VR is very good with in the training. It's not to replace the real education, but in order to repeat the material that you have already seen, VR proposes quite good advantages. And of course, still, even though it's not fully immersive yet, it's quite realistic and efficient. And as I said, the reusability is the main key there. And the same with the mixed reality, you also have the advantage of seeing that 3D object on a real scale and on real physical environment, and so that you can have an idea about how you can learn, let's say, if you're a medical student, how you need to interact with it, and it gives you a sense of reality. And it's quite engaging for the students. So I will start with some of the examples that we have done at METU. The first one is going to be HoloArc project, which we have developed with METU Department of Architecture. There, as you may see on the first row, it is how you do see the HoloArc environment with the mixed reality. So actually it is our corridor from the Informatics Institute, and it's the hologram that you are interacting on top of that. And whenever the purpose there was, it was developed both for the virtual reality and mixed reality. The idea is that the architects are using a software called Autodesk Revit, and they do model their, let's say, models there, and they need to transform and export their houses and so on. And what we had done was, we said that why don't we create like a pipeline that you can convert all those things to both the PC, VR, and mixed reality versions. And then the architects can modify those houses, let's say add a different door, add new windows and so on, and see its impact completely on real time on the Revit side as well. But also, why don't we calculate and visualize the daylighting simulation in that house? So what's going to change whenever I do add a new window to my model? What's going to change whenever I do remove a door, right? So that it gives us the opportunity to visualize daylight, but of course you can do lots of additional stuff as well. You can do most of the tasks that you do on the Revit on the whole arc site as well. You can rotate, zoom in, add stuff, trees, and the structures and so on. So you can do the same thing by using your gestures, or but if you do prefer in the mixed reality environment. And then we said that why don't we do it in terms of the design education? So most of the architecture students are like cutting lots of cards and all those papers in their first year, and they need to design something at the end. And they are taking this basic design course. But the problem is that most of the students, the first year students, are not very much aware of thinking in 3D and so on. That's why they're not familiar with how to think, how to navigate stuff or arrange things. Here you do see the background as black, but actually it is because you do see the real world. It's where you will be seeing the physical environment, and you can replace, scale, add new stuff, and you can see, let's say that you do have a real table, and you can put different objects on top of it and see how they are located and so on. So what we preferred was that instead of like starting to cut stuff immediately, first the students can have this perception and learn how to think in 3D, then they can do all the paper-based design at the end. This was the idea for the mixed reality. Actually, we did the same thing with Bilkent University Department of Interior Design, this time in VR. They also do have this basic design education, and we said that let's see the potential of doing this basic design in virtual reality, and are the students learning well, and are there any differences between the paper design or so. So what we did was we did lots of presence tests, the standard questionnaires that we are using, like technology acceptance model, effectiveness test, and so on. And the results have shown that actually the VR has a huge potential there, and also it was very much entertaining and immersive for the students who were trying that task. And then, apart from the education, we have also worked in terms of the cultural heritage. So there is this excavation place in Kayseri, Kültepe, and it is like where the first finance and all the economics has started in Anatolia. It has a very important impact in terms of like monetization and so on. And the idea was that at that time, Kültepe was trying to build a museum there, and we had talked about an app, a gaming app, so that's where the people who live that museum will continue to learn about Kültepe, so that it was having some quizzes, some short games, and some 3D models and so on. And there were like 4 main topics: education, social life, trading, law, and geography, so that it was designed especially for the museum visitors. And it had a very simple user interface, and we made the Kültepe researchers to test it. Actually, once in 2 years, there is this conference of the Kültepe International Meeting, and all the researchers throughout the world do come there and present their recent findings regarding Kültepe, and they tested our games, and the results were very positive, and we got very good feedback. Another study is eNotice. It is a European Union project, a European network of CBRN training centers. CBRN stands for chemical, biological, radiological, and nuclear activities, so that it's a network of Europe, where the idea is mainly information sharing, education sharing, and so on. That's why more or less like every 4 months, we were visiting a country and we were witnessing their education scenarios, materials, and so on, before pandemic, of course. And then the idea, the main purpose was, okay, let's do all these joint activities where we do travel to different countries and see their practices, but also let's have this web-based information platform so that where we will be using it for information sharing, communication, dissemination, and so on, so that we will focus and form a European network of CBRNE centers. And here, mainly the purpose of METU when we first entered to the consortium was to build an online game, a simple 2D game at the end of the project. This was our, let's say, purpose. But after traveling to several joint activities and so on, I noticed that actually all those joint activities are quite rule-based systems and they have lots of repetitions and so on. That's why I thought, why don't we generate a game generator instead of having a single game, so that where we can just change some assets and the visuals and so on, and then we are going to have mini games for firefighters, for hospital people, for let's say for the decontamination and so on. But in order to do that, we needed to find down the actions and event structures, and also what are the similarities between all those events, all those scenarios, and what are the key performance indicators, so that we can say that, okay, this game was successful and the students have really learned what they needed to learn. And then we had seen that also in terms of the CBRNE community. At the beginning, the games were not very much common. When I had first said that we are going to develop serious games in 2017, there was this reluctance, especially from the practitioners who were like doing all these physical activities like every year, every day. But then all the user synergy building strategies and acquiring user requirements and so on, we understood each other. We understood what were their, let's say, hesitations and so on, and what we were trying to do, so that there was a nice communication. And we said that the game is not to let's say, to replace the current education system, but it is just to map some rules and tasks to game events, so that it's to give like instant feedback. You can repeat it. You can just try to relearn what you have already learned thanks to the physical exercise, so that it's also at the end going to be an open source tool, which is going to connect the practitioners with the researchers. And we also made sure that it is not to replace the field exercises, and it's not going to be a cure for all, because whenever you do say that, okay, we are going to develop games for that, and people do have the reaction as like, aren't we going to do any more field exercises and so on. So that's why it was very important to make sure that this was not a replacement. This is a side activity and for the reinforcement. So after that, for example, this was a scenario, a joint activity in France, Nîmes. And here, everybody was playing a hospital scenario where a bomb was found in an airport in France, and they are trying to find the person. And at the meantime, there are some victims, and they are trying to arrange how the hospital should be utilized, so that the hospital is not going to run out of bed. So this was more or less the physical exercise that they were playing. But of course, at some time, so let's say that the exercise was starting at time 0, then it was like, okay, 3 hours later, and then the scenario was changing and everybody was playing in that risk and the excitement and nervous mode, for example. And most of them were real actors to give the intensity of the problem at hand. And the other one was in Brussels. You do see the real suites to decontaminate some chemical there is this chemical attack, and the police is arriving to the location, and they are trying to decontaminate the environment. That's why they do have these suits. And as I said, they are playing the real scenarios, what's going to happen when a real chemical attack happens at the heart of Brussels, for example. And then what we did was we learned all the relationship between different laboratories at that time. So who is going to talk with who, what is the task of all those institutes and so on. And then, as I said, we started to work on the scenario-based generator. So we said that why don't we create a game generator which is based on scenarios. So we will just replace the outcomes and the assets, and then we are going to have mini games. So in order to do that, we use the Unity animator controller, and there was the state diagrams available there, so that once you set who is talking with whom, who is interacting with whom, you have like the backbone of the game mainly. And then let's say that on the top row, you do see a very simple version of all those games where we were like testing if the relationships were correct, if the state diagrams were correct, if the scenario was correct at the end. And then we were just replacing the tag information of those simple shapes. And then we had the games on the below line. And on the left side, it was for the Brussels game, and the other one for the hospital game. And we had developed these both for the virtual reality and mixed reality. And what happened was that last year, just before the pandemic, I mean, it was like 24th to 28th of February 2020, all the practitioners and the consortium has arrived to Turkey, to Metu, and also then to Eskişehir. So what we did was, in terms of the joint activity itself, you do see this mine there in Eskişehir. It is actually an overground mine, and we have made a complete replica of that. And what we did was they played the mining game in both mixed reality and virtual reality. And also they played all our games like the PC and the VR versions of the hospital and the bioguarding game. And it was very important that they tested those games because they were also there physically when the physical exercises were there. So that they had given us feedback. And so on the top row, you can see the replica of the mine in Eskişehir University, and on the other, let's say, lower part of the screen, it's another hypothetical mine that we had developed for the master thesis of our student who had graduated a month ago. And then this is just a recent study. During the pandemic, we said that why don't we make all these laboratories and so on, why we do have the distant education as games. And then we collaborated with civil engineering, Nejan Huvaş Hoca. And the funny thing is that we have never met face-to-face. All the game was built online with Zoom meetings and so on. And starting from next week, the students of the soil mechanics course are going to play that game. So these were mainly, let's say, the serious games part and the applications that we were doing. Now we will switch to a different mentality, but I will just give a brief overview of things, and I will skip most of the technical details and so on, just to give you some idea about, okay, so far we have developed games. What if we have created some entities in the games or in different test beds to do some other tasks? That's going to be the second part of the talk. I don't know if you're familiar with it, but the reinforcement learning is a subset of the machine learning. I'm aware that Merih Hoca and Pelin Hoca have been working on those, but just for the audience, I will briefly mention it. So it's a completely different machine learning task, actually, when you think about supervised learning or unsupervised learning. Here we do have this entity, which is called agent, and this agent is receiving some observations, some information around from that environment, and make some actions. And after those actions, the environment gives the rewards to that agent. I mean, you can think it like our learning when we were like kids. Our families were saying to us that, okay, don't touch that fire. But of course, we were, as agents, we were very curious about it. And of course, we were touching the fire, and the fire was giving us some pain feedback, right? Rewards. And we were understanding and learning that, oh, okay, this was not a very good action and so on. But it was just like a one-time thing, right? And think about this as like a sequence of decisions. And all this model repeats itself. So you're doing something and the environment is giving you something and your state is changing. So think about it like you are doing something in a game, and thanks to that action, you are winning some points, you are arriving at a point, and then another enemy arrives. And so the actions do unfold, right? But the thing is that in the overall purpose in general, of course, this might change due to the nature of the problem. In general, our main purpose in a game is to arrive to the maximum reward. So that I do need to have such a sequence of steps. When I do arrive at the end, I'm going to have the highest score, for example. But this is in general true for game playing. Or think about the strategies in life, or think about the things that you are doing in life. Sometimes you may know that that action always gives you the best choice. So you may have like your favorite restaurant, and you may continue to go there. It is called exploitation because you know that that action is quite good and you're just repeating yourself and you're not taking any risks. However, in life and also in reinforcement learning, you need to explore sometimes. You need to take some risks. So because maybe the summation of other rewards is going to give you a better choice or better outcome and so on. And this was the thing for the game playing. And we said that, why don't we create some agents? They will not be programmed or trained, to be honest, to play the game, but they will be trained to test the game. So when you're talking about testing the game, that's a completely different thing, isn't it? Because there you are not only trying to win, or you are not only trying to arrive to the exit, but you are also trying to check if whenever you hit the wall, is it really a wall and hits you back? Or are there any bugs out there and so on? So you are just trying to create some alternative paths, right? So we said that, why don't we use the general video game AI? It is in general to create like very simple games, grid-based games, and you can test your AI there. We said that, why don't we use this environment to create test agents? And in order to do that, we said that, what if we do have like synthetic test goals? So the test goal is something that we would like to test as a path in the game. As I said, it doesn't need to be like the correct way of finishing the level or so on. In the end, we will be trying to create some alternative paths and alternative realities so that we can test if there are any bugs or so. That's why it is called synthetic game paths, test paths. And then we also said that, why don't we make real game testers to test our game? And then we will be acquiring their test paths. And why don't we use this information to create human-like test agents so that they will have this human-like touch on them? And our study has shown us that actually that human likeness has helped us to create even more bugs, to find even more bugs in the game. And also the synthetic game engines gave us the opportunity to navigate different test scenarios which were not available at the beginning. So this was a very good outcome for us. Then we said that, and we tested it with different agent test ways. One of them is the Monte Carlo tree search. I will briefly mention that. And the other is SARSA. It is like state action, reward state action, and you're trying to understand what's going to be the next and to extract the policy out of that environment. So with the Monte Carlo tree search, it's a heuristic search where you are at the beginning, again, starting randomly, selecting a node, and expand it by taking some actions, and you go to different action items. And after a while, you just simulate and continue in a way more rule-based, but then come back and backpropagate and update your probabilistic outcomes so that to understand which path was better. And again, this is mainly used with game playing. We said that why don't we use it with game testing, and why don't we make some enhancements? I'm not going to go much to the technical details here, but what we did was we used some strategies, like sometimes we reuse the node information. Sometimes we had said that, okay, we will be only doing very bold actions. Sometimes we said that, okay, we are going to increase the randomness in the tree and so on. So we tested all the strategies with, again, on the GBGA environment, again, with the synthetic and the human-like agents. And we had seen that all the enhancements that we were adding to the game were actually helping us to extract more bugs so that they were increasing the game testing performance in the overall. And as the levels were increasing, the grid size and the complexity of the entities to be found was also increasing. And we had collected 427 trajectories from 15 people, again, to create like human-like behaviors. And our main questions was, I mean, whenever we were testing different computational budgets, what about its impact when we are creating this game testing agent? Which modifications did actually help us? As you may have seen, we have tried several things there. And if they were way more functional on the SARSA or the Monte Carlo tree search, and were these modifications really powerful on the human-like agents as well, or were they only with the synthetic agents? And these were, we had a very detailed cross-entropy and trajectory length-based comparisons, and our results have shown that actually the modifications were useful, but still it was dependent on the type of the agent, so that we need to come up with more generic methods actually. And this is actually the final part of my talk. Again, I will just briefly introduce another, let's say, domain. I do find this section quite interesting. It is relational reinforcement learning. So let's say that, okay, we are working on creating all these reinforcement learning agents. We are giving them rewards. We are checking their outcomes and so on. But it's quite, we do have quite reward tuning there, right? What if I do have an environment where I can extract the relationship between the objects in the environment? So this was a question that was asked in 2018, and it has become like a baseline. This is the box world environment, and they have created some relational networks, and they created some questions where we had like visual outcomes, and it was possible to ask non-relational or relational questions. With the non-relational question, for example, one of the questions is that, is the yellow object on the top or on the bottom? It is just dependent on the feature of that object itself. But a relation question is, what is the color of the object that is closest to the blue object? So that our purpose was to, their purpose was to understand what is their relationship between each other, and they had created this box world environment where they had used the multi-dot-product attention network to understand which component is way more closer to the other one and so on. Actually, this network was mainly used in natural language processing, so that, for example, the verb has way more connection to the object of the subject of the sentence, for example, and they used the same logic with the images this time, and they acquired quite good results. And this has become a baseline. And then there was the Prednet Architecture. This was another network where they actually formalized these outcomes in the Prolog language, so that it was giving like the logical statements as outcome. And it was a very powerful thing. So, for example, you had all these, again, visual inputs. On the left side, for example, if these objects are between each other, in the first one, it is false. The yellow one is actually between the pink ones. I'm checking on the last column. And and on the final one, gray object is between the green ones, and it's true, for example, so that it was creating the propositional outcomes of the objects. And it's a very powerful thing because it helps you to generalize things, interpretability is increased and so on. And then it gives you the Prolog answers so that you can have the, in a way, the formula of that scene. Then we said that with my students, okay, the box world is very simple, actually. I mean, you have these objects on the left, on the right, top of each other, and so on. We said that why don't we create a game-like grid world where we can like have enemies, and there will be difficult relationships, so that, for example, to kill an enemy, first of all, you need to take the sword, or you will have like teleportation. There will be like mountains, pits, and so on, different objects where you will be colliding into. And we said that why don't we create such a thing? This is the box world, a very simple one. And this is our world where there is this agent, the terminal states, teleportation action, walls, mountains, enemies that we do see in a game mainly. That's why this has enabled us to create lots of functional and action-based environments. And our purpose was, if the agent, after plays and interacts with these environments, does it learn the relationships between these objects? And to do that, we had given the trained outputs of this system to the Prednet, and we were able to extract their outcomes. And we had also tested our configurations with the box world configuration as the baseline, and we had seen that more or less our, let's say, learning rates were quite similar, and also the way the reward design was, how the reward design was done was similar. So the main contribution was that we had produced a way more complex functional relational representation environment with a relational agent, and we had shown that they had worked similar to the baselines, and it was an achievement when the complexity of the question that we were asking was considered. So that's it from me today. Hope you enjoyed it. Thank you very much for this nice invitation.
Thank you so much, Elif Hocam, for this truly inspiring presentation. I certainly learned a lot. And also, let me take this opportunity to thank you on behalf of GLODEM as well. And on that note, I will open the floor for questions or comments. If you could put that in the chat box, that's fine, but it would be, I guess, easier to just unmute yourself and ask. So I'll be collecting questions now.
So maybe not a question, but a comment. So this was the best explanation of reinforcement learning that I've ever heard before. So I really
thank you very much.
Like, so this is really like for anybody to understand, I think. I wouldn't be able to explain it so well.
Thank you very much. I mean, this is very flattering. Thank you, Pelin Hocam.
Well, this was a great presentation. Elif Hocam always makes great presentations.
Thank you very much. I mean, actually, I was worried that in the e-notice section, Pelin Hoca has watched this, I think, at least 3 times before. So
I love watching it. So I really believe in the usefulness of this work a lot. So, and I always, every time I watch it, I still enjoy it. So
Thank you very much.
I mean, coming from an absolutely different field, I didn't have any difficulty understanding actually the presentation. Everything's so crystal clear and also very inspirational in the sense that it is really open to interdisciplinary work, particularly if it's social scientists. So, I mean, if there aren't any questions at the moment, we usually have this like, you know, pause for a couple of minutes. People try to, you know, get their hands around like what they would like to ask. So I usually use my moderator privilege at that point to just ask my questions or add my comments. So I was wondering, because I mean, you actually are using this in different fields, and you already gave us instances of like how firefighters might make use of it, or the other instances you gave. And I was wondering how we could maybe integrate this to our field of study, that is international relations, decision making and international relations, or how we could, I mean, obviously I'm just looking for some new research questions that I also would benefit from, but it just looks super interesting. We do use computational simulations, but they're obviously very different from what you are doing in the serious games. And so just brainstorming a little bit here, actually.
I think that's a very good question. As you said, Merih Hocam, there are lots of like simulation-based studies actually in the social sciences. And what they do is that they do use like multi-agent models in order to model the different groups of people, how they do behave and so on. And then they do add what if questions and just to check what would happen if that group of populations have preferred to eat this instead of that, and so on. Or sometimes we are using it in terms of the data visualization. What would be like the movement of the groups of populations from one area of time to the another, and how the things have changed, and what would happen if the climate was different. So you are like changing the parameters and you are observing their outcomes on the population. But the population also acts as like different agents, so that they do make different choices and so on, and they may collaborate or compete and so on. So there, I mean, I have read a lot on those things, and I would be very happy to investigate those sort of problems, because in the end, the research question is going to be the main thing, which is going to be like the heart of the research question there. But in the technical side, it's going to be just the modeling as in terms of multi-agent problem, either collaborative or competitive with by changing the world and the environment parameters, basically. So this was the first thing that came to my mind, because I was very, I really would like to implement something like that in the long run.
Oh, I would love to, because negotiation is at the very core of everything I do, actually, in academic sense. So definitely, we'll talk after the seminar, I guess. I think there's a question in the chat box. Alihan Öztürk is asking, and I will read it out loud for those who are listening to the recording of the seminar later. What do you think about setting up the reward function? I guess this is one of your big challenges.
Exactly. I mean, I think it is the worst part of reinforcement learning. I mean, it is the main lack of things, because again, it's like teaching somebody something, right? If you're like very strict with your attitudes, that person can get irritated. If you're just like very sweet and don't worry, maybe they are not going to learn at all. I mean, just think about our interactions and so on. Even arranging the tone of that is very difficult. It is the same for the reinforcement learning. I mean, I'm very much fascinated by the reinforcement learning in terms of the research topic, because there are lots of possibilities. And also the reinforcement learning is like the games are like the test bed of the artificial intelligence, and there are completely different things to do. But it is, let's say, the weakest link. It is the most let's say manual, to be honest, stuff. And that's why now we are way more to understand and train things on the perspective of the symbolic AI and going back to all those prologue interactions, and so that we will have at least a mathematical background while also tuning all those rewards and so on.
Thank you. Any questions at the moment? If not, I have another. Oh, sorry.
No, it's
Go
okay.
ahead.
I'm sorry, my
No,
video
go
isn't
ahead.
on,
No,
but,
absolutely. Go ahead.
I'm Elif. I'm a PhD student. This was very interesting. And I actually have a question more about the market of these games. So you talked a little bit about the different, I guess, like areas that it's being used in, but I was curious about if there's companies specifically both in Turkey and outside of Turkey that are investing into these areas. I was just curious if you had any information about that or any ideas. Yeah, thank you.
Thank you very much. Actually, if we do think in terms of the video games, like the regular games, I mean, Turkey is quite successful on that. Actually, last week, I think the first 6 games on the Apple's list was from Turkey in top 10. So we do have a huge mobile game market here, and in Metu, we do have the Atom, the incubation center, and they're doing very nice stuff where there are like small companies and the indie gamers, and they do develop very different games. And also in Istanbul, there are lots of important companies. In terms of the serious games, for example, we had used this system in different hospitals in Milan, or I do have some friends who were working with the mental impact of the pandemics with games, and they had made lots of negotiations with the hospitals again in Italy. So they are using it a lot as a side part of the rehabilitation. In Turkey, we worked with the attention disorder kids with dyslexia, and we were very happy about the results, and we will give our games to them as free so that the students will use them, and they will be able to change their materials as well. I mean, their teachers will be able to change the materials as well. So I think there is a huge potential there, because now we do have a different generation coming, and they are learning in a very different way. And also, it is not only true for the young people. Whenever I went to different people to test our games, it can be for neglect or stroke. I mean, and these people were like 70 plus, both in Turkey and in Italy. And they always thanked me because of the fact that for the first time for a year or 2 years, I didn't think about my health or my illness, but I thought about how am I going to take that apple from that damn tree. For that hour, I didn't think something else, and it was huge, such a huge relief for me. I mean, this was the main reaction that we were receiving from the patients. So that's why I really do believe the benefit of the rehabilitation with serious games, because in the end, you are talking about like, after all the hospitals do discharge these people, for example, they need to do like at least 30 sit to stand by themselves. And whenever you are sick and old and you are at home alone, I mean, it requires a lot of motivation to do such a task. But with the games, for example, in one of those, we were riding a horse. That's why you need to sit down and stand up. It was just there. And they were not even aware that they had finished their daily task. That's the magic there.
I see. Thank you.
Thank you.
I was just curious if like Google has been interested in this type. I mean, I feel like this is with AI, it could go hand in hand with what they're working on. So I was just like wondering if these bigger companies are also thinking about how to.
DeepMind, for example, they have been working on reinforcement learning for several years, and also the AlphaGo, how they solved it. It is all based on reinforcement learning, and deep reinforcement learning is a huge thing now. What they achieved was that they had like loaded hours and hours of gameplay from the computer screens, and then the deep learning was able to understand the relationships and how to play the game, for example.
Thank you very much, Hocam. As I said, I usually give some time to our audience to warm up a little bit and put their questions in the chat box. So that's happening now, but I also see Nehir's hand raised. So I'll just first give the floor to him, and then we'll be back at close.
Hi, thank you for a great presentation. I've got a question. It might be a little bit off topic, but I hope it's still relevant. I've got a question about serious games. You have showed us very great implementations, but I think there is an other side of the coin regarding the market. So far, I have been like participating in many serious game / tests by companies and by non-governmental organizations, from OEC to McKinsey & Company. Many organizations use these kind of serious games to test their participants. But generally participants are not briefed after the game about their results, or they are not briefed about why they were not elected or they were elected. Do you think, is there a moral hazard for that? Because I see right now many companies and many organizations are using serious games as tests for like admissions and all, but I think that also brings a component of moral hazard, as you cannot simply study or work for the game, but it's like more random. You don't know what's behind it, so it's hard for you to understand why you were chosen for or why you weren't. Do you think in the long term
I'm not sure if I understood it well, because in our cases, whenever you need to test such serious games, for example, in Switzerland, we waited like 1.5 years in order to have the ethics committee's approval, and it was on a voluntary basis. So we didn't choose the subjects. Subjects have chosen us.
Yeah, I'm actually asking for like many companies on the market. Like I said, that could be a little bit off topic. What's your opinion about like?
I mean, to be honest, I was not very much aware of that. So I think what you are saying is that there will be some privileged and rich people who will have access to those games, and the others will continue with like traditional rehabilitation, something like that, or?
Not necessarily rich or like privileged people, but I'm saying like these kind of games are being used by the companies a lot nowadays. Like I participated maybe 20 of them, and they use that for their candidature process. Like when they are like offering people jobs, they first these kinds of games, and you cannot study for that. You cannot do anything about it, and like
I mean, it's a very generic topic. I think I can talk like for 2 hours at least. I mean, of course, every coin has its like dark side, let's say. And I mean, even, I'm working on the agents and artificial intelligence and so on. But whenever I'm calling my bank, and if I cannot reach a human speaker at the end, I get frustrated, and they don't get my Turkish, and I do make different choices, and I'm like, oh, where are we going, and so on. Did we make this? And so I do panic. I mean, in the long run, we need to have lots of ethical questions, and while we are implementing all those things, we need to think about those as well, so that we need to think about if the AI is really going to evaluate the job selection well enough, or are the emotions will be important, or this and that. I mean, it's a huge topic. I understood now the scope that you were talking about, but I mean, we need to think about all those things. At the beginning, we are focusing only on the good side of things, but then we need to consider what if people or the AI misuses it, and what will be the consequences of that. So that was a very good question.
Thank you, because like I was always wondering.
Yeah, but
sometimes we are getting results and we don't know why the AI chose those results, and I think that in the long term we're gonna cause a big moral hazard. Not maybe now or not tomorrow, but in 3 years, people will be chosen based on things that we don't know. And I wondered what you were thinking about that as you are working in that field. Thank you.
I mean, we need to make like ethical design choices. We need to consider all these, let's say, side problems and the dark side as well.
Thank you very much. And actually that applies to all fields of AI.
Yeah.
It's a philosophical issue that we all are wondering what the correct answer is, and there is no, I guess, correct answer, but I'm sure Pelin Hoca would say keeping human in the loop would be the answer. Just putting you on the spot, but we have another question in the chat box. I will just read that out loud. Oğuz Bulutkök is asking, in the experiments that are based on the interaction between individuals and environment, simulating a realistic setting is highly important. Excuse me. However, some situations, as you have mentioned, might be time-consuming, repetitive, and costly to replicate. Can the use of serious games and mixed reality help to enhance the realism of these experiments? And what are the possible drawbacks for the use of these methods in experiments?
I mean, the first question is definitely yes. In terms of like creating repetitive material, in terms of especially physical education, as I had mentioned, they are like making drones fly on each of their exercises. They are making like 100 trucks of firefighters to arrive to a location and just fire extinguish that place and so on. You cannot do this every day. And this exercise is done only once a year. And our purpose is that, okay, let's participate to that as well. Let's observe it. Let's be players there and interact with it. And then when we go back home, why don't we play it on our tablet or on our headset so that we will be still having the, let's say, the experience ready for ourselves, and we will be just repeating the action, and so that we will not be forgetting the gaps, so that we will be remembering, okay, in this game my role was the firefighter, or I'm now playing as a nurse and my task was this and that, and I needed to talk to the medical doctor about this first before doing that action, and the other option was wrong, for example. So it's going to show us the gaps that we have most probably didn't even notice in such a fixed scenario, for example. And the drawbacks would be, of course, in the end, when we are creating the scenarios, we are trying to replicate things, and I think we need to work on more in terms of the evaluation, and also in terms of teaching alternative tasks as true as well. Let's say that I'm achieving one task by one methodology, but actually another alternative was also possible, and we are very good at that in terms of human beings, with in terms of creating like creative opportunities and the options and so on. And we need to have that flexibility in our game so that we can still propose different, let's say, scenario jumps or action items and so on. So we need to have that natural, valid vividity of the task at hand. And it is very difficult for now.
Thank you very much. I don't see any questions in the chat box at the moment, so I will again use the moderator privilege to ask a question myself. I had the opportunity to attend this data science for the public good workshop kind of yesterday. It was organized by TED University's Data Science Center, and it was one of our undergrad researchers who was presenting there too, and a project about immigrant integration. Made me think if you are aware of any studies utilizing the serious games for integration of immigrants into society.
Yeah. Actually, I do remember that with the Syrian refugees, they have made some tablet video games to teach them Turkish with serious games, and the kids were very happy about that. Both they were learning a language, but also they had this immersion and doing something, because in the end, games give us a sense of fulfillment as well. I mean, whenever, let's say that we had a terrible day at work, and after we do arrive there, we do achieve a few tasks there, and it gives us back our self-confidence, for example. And it was very important for the Syrian kids in that sense. Okay, I learned that sentence, I was able to do that, and I learned it in a very friendly environment, and the results were very positive.
Oh, that's great. Well, thank you so much. Any other questions? If not, I will continue with more philosophical ones. I'm just kidding. But I mean, I really, it just, you know, I pretty much actually asked the same question to myself. You know, I mean, is it actually better if you just let, for instance, for peer review process that I am very skeptical of, should we just let AI do it? So that it would be, you know, much more objective. But obviously there are difficulties there as well. I mean, so that's why the question that Nehir asked is, I guess, applying to, you know, all the fields using AI. At the end of the day, we are the ones setting the rules, and should not then put the blame on AI if the turnout is not as expected. But I also get really frustrated when I have to talk to AI on the phone when I'm trying to reach my bank. A trick I learned from a friend is to just say, just tricking AI here, obviously, to say, I would like to change my address to reach a real person.
That's a very key. I'm very happy to have learned that, because it really frustrates me. I mean, at the end, I want a human being at the end of the phone. I want to talk with someone. So, but
I remember once I ended up in the, sorry.
Merih Hocam. I mean, I have never thought about peer review process with AI. I mean, that would be very interesting. I'm not sure if the comments would be as sarcastic as the ones that we do receive recently, but I think if we train them like that, we will have that potential, most probably.
Yeah, I think we first of all would get rid of the sarcasm. At least we could control how polite the reviewers would be, hopefully, or we could just, like, you know, just like tweak the system a little bit and make AI a little sarcastic every now and then. But certainly wouldn't miss the absurd sometimes reviews that we get. I just recently got some really interesting feedback from some reviewers for another paper that we're working with some with a couple of my co-authors, and that was the conclusion we reached. Maybe we don't need humans to do this. Maybe we should just outsource this totally and let AI do it for us. But obviously, as Pelin Hoca keeps saying to me too, it's important to keep human in the loop. And I think that is the key to the problems we talk about in AI. The research you presented is so inspirational. It's just giving me so many ideas. Elif Hocam, thank you so much. I cannot thank you enough for this really informative and really inspirational talk. If you have any other questions from the audience, I guess you can reach Dr. Sürer from this email address. Sometimes our students, we do have some students in the participants, they may be shy about asking questions. But if they do, indeed, they can then reach Elif Hoca. So thank you all very much again. I will pause recording.